This is the final type of outcomes that we study in clinical research, the time to event outcomes. First, let's review the risk ratio quiz. The correct answer is 0.8954. You have to calculate the log of the limits of the confidence interval, then calculate the midpoint, and then using the anti-log to calculate the risk ratio. Time to event outcomes are actually unique. It's a type of outcome that we find in many medical studies. Such events may be adverse, such as death or recurrence of tumor, or positive, like conception, pregnancy, discharge from hospital, or neutral, like the time to completion of breastfeeding, weaning. It's conventional to talk about survival analysis and survival data because it was first used in 5-year survival in cancers, regardless of the nature of the event. Similar data arise when measuring the time to complete a task, such as walking 15 meters or something. Time to event data is unique because the outcome of interest is not only whether or not an event occurred, but also when that event occurred. The distinguishing feature of survival data or time to event data is that at the end of the follow-up period, the event will probably not have occurred for all patients. For these patients, the time is said to be censored, indicating that the observation period was cut off before the event occurred. We do not know when, or indeed whether, the patient will experience the event, only that he or she hasn't done so by the end of the study. Censoring may also occur in other ways. Patients may be lost to follow up, like the figure that you see. Some patients didn't complete the full time of the follow-up period. Or they may experience a competing event, which makes further follow-up impossible. For example, patients being followed to a cardiac event may die from other disease or in an accident, for example. So we do not know if the patient would have, he or she completed the study, would have the event or not. So the event is censored. We don't know. In most survival studies, most studies that report time to event outcomes, patients are recruited over a period of time and followed up for a fixed date beyond the end of the recruitment. Thus, the last patients recruited will be observed for a shorter period of time than those recruited first and will be less likely to experience the event. This is an important assumption, therefore, that all patients stay the same throughout the study. This is not usually the case, but this is our assumption in order to report this type of outcome. We also assume that patients lost to follow-up have the same prognosis as those remaining in the study. So at the end of the study, patient number 1 in the figure didn't have myocardial infarction. Patient number 4 dropped out after 4 years. We assume that he didn't have anything. He didn't have myocardial infarction, he didn't die. So we assume that 4 years although this is a small period, the time of the study is 10 years, the follow-up is 10 years, but patient number 4 was only followed for 4 years. He didn't have the outcome. So assume that this patient is clear of the outcome, although he was not followed up for 10 years, but only for 4 years. The hazard ratio is the way we report time to event. Hazard ratio simply is a relative measure, like risk ratio and odds ratio, of an effect of an exposure on an outcome of interest over time. So the denominator is not the number of persons in the study. It's the number of persons multiplied by the time they spent in the study. Hazard ratio is the ratio between the event, the rate in the exposed group divided by the hazard, which is the incidence rate in the non-exposed group. This is an example of a published article, the association of added sugar with cardiovascular mortality. They follow up patients for 10 years and they reported the hazard of dying young in those who take 25% or more of their daily caloric requirement from added sugar compared to those who take less than 10% of their caloric intake from added sugar, and the hazard ratio is 2.75. This is the same interpretation of the risk ratio. So it means that the hazard of a cardiovascular mortality in adults who take more than 25% of their caloric intake from added sugar is 2.75 times the hazard in adults who take less than 10% of their caloric intake from added sugar. Similar to risk ratio, the difference is the denominator is not the number of persons, but the number of persons time. In every estimate, we have to report a measure of precision, confidence. Are we confident of this estimate 2.75? This is called, as you know, the confidence interval. The formula for the confidence interval for relative measures like risk ratio, hazard ratio, or odds ratio is a bit involving, so you don't have to memorize the formula, you have to get the idea of that formula. The 95%, when we calculate 95% hazard ratio for added sugar, and we find that the 95% confidence interval of cardiac mortality in adults who have 25% or more of their calories from added sugar compared to those who have less than 10% of their calories from added sugar is 1.42, 5.42. This means, narratively, this means that we are 95% confident that the true population, this is our estimate from the sample, we need to infer on the population. Population means everyone on Earth. We are 95% confident that the true population hazard of cardiovascular mortality is 1.4 to 5.42, comparing 25% or more with less than 10% of calories from added sugar. That's it. Thank you very much. Remember that every cell counts, and stay safe.